6-4, using inverse function. Okay, focus. Inverse function. An inverse relation means that it interchanges the input and output values of the original relation. So if my original relation is my x inputs are 0, 1, 2, 3, 4, my y outputs would be 6, 4, 2, 0, negative 2. My inverse to that would be that my outputs are now 6, 4, 2, 0, negative 2. And my inputs are now that, and my outputs are now 0, 1, 2, 3, 4. So your outputs and your inputs switch where they are located. Okay? Your original outputs become your new inputs. Okay? And so that's what we're looking at when we're looking at inverse relationships. Okay? If I want to find an equation for the inverse of a relation, it's very, very simple. What you do is you switch x and y and resolve for y. So you're going to switch x and y, and then you're going to resolve for y. Okay? So if I want to switch x and y and resolve for y, how would I start to figure out what the inverse of y equals 3x minus 5 is? What would I need to do? How would I set up a new equation to figure out what the inverse of y equals 3x minus 5 is?
You would do y equals,
No.
Oh, what?
First step is to switch.
Oh, switch x and y.
So that means instead of y equals, it's
X equals.
x equals 3y minus 5. Now what do you have to do from there?
Solve for y.
Solve for y. So how do I solve for y from here? How do I get y by itself?
You
Guys, you've done
would
this.
add, what do you add 5?
You would add 5 to both sides. You've done this before. Nothing new. So you get x plus 5 equals 3y. Now what do you do? Y. How do you get y by itself?
Then you divide.
Divide by
3.
3. So your equation would be y equals x plus 5 over 3. That is my inverse function of y equals 3x minus 5. You switch x and y, you resolve for y. Okay? Switch x and y, resolve for y. What happens if I have this equation? We're going to try another one. What happens if I have f of x equals 2x minus 1? How do I find the inverse of that function? Where is my y technically? F of x.
Yeah.
So I can rewrite the equation to say y equals 2x minus 1. Now, how do you find the inverse?
You switch x and y.
X equals 2y minus 1.
Good. Now what?
Add 1.
Add 1. X plus 1 equals 2y. Now what?
Divide by 2.
Divide by 2. And y equals?
Y equals x plus 1.
Be quiet, Siri.
Over 2.
Beautiful. Good job, Drew.
You want your-
Okay. So that's how I solve for that type of equation. Okay. Now, if they give you two equations and they say prove that these are inverses of each other, you have to be able to say the function of g of x, when I plug a function into a function, yes? And it has to come out to equal x. And you have to do it the other way. The function g of f of x equals x. So here it says verify that f of x equals 3x minus 5. And f, that negative 1 up there, means the inverse function of f of x equals 1/3 x plus 5, are inverses of each other. So to prove they are inverses of each other, I'm going to underline this in green and underline this in blue so we can color code it a little. Okay? To prove they're inverses of each other, first I have to prove f of the inverse of f of x. Okay? That means what am I doing? I'm taking that top equation, right?
Multiplying.
Not multiple. What am I doing to that top equation where there is an x?
Oh, you're substituting
What am I substituting in for?
the inverse.
The inverse equation. 1/3 x plus 5/3. Okay? Minus 5. Now, what this rule says here is when I do that, my answer should come out to say x.
Yeah.
If it doesn't come out to say x, they're not inverses of each other. If it comes out to say x, then I have to do it the other way as well and double check that. So, what is 3 times 1/3?
1.
1, so just x then, right?
Yes.
What is 3 times 5/3?
5.
No. What's 3 times 5?
15.
Oh, okay, yeah, you just went ahead. And then 15 divided by 3 is 5. So I get this. Now, x plus 5 minus 5 gives me what?
0. So then would that be 1?
X
Oh.
plus 5 minus 5 gives me what?
X.
X. So right now, that checks out right here.
Mm-hmm.
Now, I have to do the inverse of f of x. Okay. So, how do I plug that in? What do I need to do there? Anywhere there is an x in this equation, what do I plug in for it? Anywhere there's an x in the inverse equation, what do I plug in for it?
The other equation.
The function
Yes.
equation, 3x minus 5. So I have this. Okay. What is 1/3 times 3x?
X.
X. The 1/3 and the 3 cancel. What's 1/3 times negative 5?
Negative 5/3.
Yep. Plus 5/3. And x minus 5/3 plus 5/3 gives me
X.
x. So those are inverse functions of each other.
So it doesn't equal x basically the first time. Let's say that you have
If it doesn't equal x the first time, you don't have to go further. But it could equal x the first time and not the second time, and
Okay.
it would still not be an inverse of itself, okay? Let's do one more inverse one, and then, let me find one more inverse one. And then we will stop there because we're going to do graphing tomorrow. Okay, let's verify this inverse. The first one is, I'm just going to do these in 2 different colors. F of x equals 2x plus 3. Okay. G of x equals 1/2 x minus 3/2. Okay. What do I need to do to solve these to verify that they are inverse functions of each other?
To f
Uh-huh.
of the inverse function, or yeah, inverse
F,
function.
no,
G.
yeah, f of g of x. This time it doesn't have it labeled as the inverse function. So, how do I set that up? 2 times what?
1/2 x
Uh-huh.
minus 3/2.
And then plus 3, right? What's 2 times 1/2 x?
X.
X. What's 2 times negative 3 seconds?
Negative 6/2, which
Yeah.
is 3.
Negative
3.
Negative 3 plus 3. So x minus 3 plus 3 gives me
X.
x. Now, what do I have to do to continue to verify it?
Do the other one.
Okay. G of f of x. Okay. Which means 1/2. And then I plug in 2x plus 3 minus 3 seconds. I need to see all this work when you do it on your homework too. What's 1/2 times 2x?
X.
X. What's 1/2 times 3?
3/2.
3/2 minus 3/2. X plus 3/2 minus 3/2 gives me,
X.
so yes, they are inverse functions of each other.
Okay, so even when it doesn't have the f and then -1,
Correct.
You still have to.
You still have to plug them into each other and see.
Okay.
Okay. So that is what we are working on today.